question. Okay, so I've got many questions. So first of all, how difficult is it to move from divergence gradient to curl? I mean, no, okay. I mean, do you have some kind of strategy to look at the vectorial problem? So,
I mean, I think the most difficult part might be about the linear theory for sign-changing curl operators.
okay.
But for the nonlinear part, it shouldn't be too hard to generalize this to the curl part.
Okay, so really, the linear part is not incremental, but once you break down this problem, okay. I've got another question. I was not too sure. What is the assumption on sigma? What is the regularity of sigma?
You can take, at least for the talk, I assume that sigma was constant by piece. I didn't really say that. So the assumption on sigma is that it is an n-infinity function.
Okay.
And it's not just positive, but really like greater than a small number that is positive on the positive part, and on the negative part also it's lower than a small negative number. So you cannot get close to zero.
Okay. Another question, I think people would be interested by that, is so far sigma is a scalar. Can it be matrix valued? Can you have two anisotropic media with different, one is positive definite, one is negative definite? I mean, you know, but matrix valued. Anisotropic media. So can this be done, or?
I want to say yes.
Okay.
I think it shouldn't be too complicated. And if you have a self-adjoint operator behind this, it should be okay, I think.
Okay, interesting. And besides from that, I'm not too sure about the regularity of gamma.
The interface.
Yeah.
This is hidden in this T-coercivity property.
Okay. Can we review it again then? Can you?
Yes. So if the interface is smooth, you don't have any issue. I mean, you can, what I mean is, if the interface is smooth, you will be in this setting where the only problem is if the contrast is -1. What is if you have, if the contrast along your interface is -1 somewhere.
Okay.
And if you have corners, you can have corners, but you will need to, in a sense, remove, this is called a critical interval. So you will not have access to all the contrast possible. You need this contrast to be outside of this interval. And this depends on the corner. If you have, but this is still in a case where you have corners, and you have smooth by piece interface. If you don't have that, I have no idea.
And can you have some kind, so here, so you can have a finite number of corners. So you can have, okay, countable as well. I mean, what would you?
I don't know.
Yeah.
I mean, I don't know if it's if you can have this T-coercivity property
kind
for, I mean, you might need to ask like Anne-Sophie. Anne-Sophie might be able to answer this kind of question more precisely.
Yeah, and I've got another, crazy question. Like in terms of the non-linearity, so it's cubic U. Can you which power of U can you have? Can you think of any other power?
Yes. So here I put 3 because it's easy. But you can actually do more general non-linearity.
Okay.
What is the range of power you can do? I on the top of my head like this, I don't know, but maybe Rainer can.
I can if you like.
Yes, sure. Please.
Okay. Yeah, I can step in. So what you essentially need for these bifurcation issues is that your nonlinearity is superlinear near 0. So first of all, you need that this is that U cube could be U to the alpha, where alpha is bigger than 0.
Okay.
Bigger than 1. Sorry. But if you're supercritical, so in higher dimensions, so say when n is equal to 3, and you're approaching the critical exponent for the Sobolev embedding, then the global picture might get a bit complicated. But anyhow, you will observe a local bifurcation at least. So what is crucial is that you have a superlinear nonlinearity. So we could have done everything for a superlinear nonlinearity. I think that's the essential things. Yeah.
And what is the sticky point for alpha, which is between 0 and 1? What's the bottleneck of? I mean, yeah.
Bifurcation theory is based on the idea that the governing the governing part for small solutions is the linear one. And if you have a sublinear term on the right hand side, then it's the sublinear one that governs the behavior of small solutions.
I see.
Yeah?
Okay, I see the philosophy. All right. So and again, in terms of sigma, can you think of so sigma again, which is anisotropic? I mean, because Zoïs said it shouldn't be too much of a problem. So this is something incremental, or it's a big change in your theory if sigma now is matrix valued, or even perhaps degenerate. I mean, you can have sigma. Let's say you can have sigma. These things. You can have sigma with 1 positive eigenvalue, 1 negative eigenvalue. Use this kind of indefinite media, and then you would have 2 types of indefinite media, but with the switch of the. You see what I mean?
Yeah, I think Zoïs said the right thing. So I would also suspect that if sigma changes sign, so is a positive definite on one part and negative definite on the other part, then we should observe exactly the same. Where if it's an indefinite matrix on both sides, well, that could be a delicate issue. I don't know, but in this case, the whole concept of T-coercivity might break down, or at least the ways to verify it must be rethought, so to say.
Because these are media of special interest. Yeah, these are media of very special interest, and people now they like to organize this indefinite media, but in some kind of funky fashion. So with different kinds of opposite kinds of indefinite, features. Anyway, so yeah, fantastic. I love what you guys are doing. So anyone else wants to come forward with a question? It could be, any question is really welcomed. Okay, so I would like to thank our speaker again for this absolutely fantastic talk. I really love what you're doing, Zoïs. It's really, really nice to see that metamaterials is also a field of interest for people who do more abstract mathematical stuff, but this is invaluable for engineers and physicists like me. And with that, I would like to remind people that next week we will have Vladimir Shalaev, so it will be way more engineering, and it will be a talk also that can be of interest for pure mathematicians like Zoïs and Rainer. So thank you very much for your attention and stay safe. Bye-bye.
Bye. Thank you.